Good morning, good afternoon, good evening. This is Mr. Pane bringing you Unit 6A, Lesson 3. There are many types of sequences, but there is one that is related to linear functions, and it is a type of discrete linear function. These are known as arithmetic sequences. Let's illustrate one first. So in that first sentence there's a couple things I want you to highlight and underline. I want you to make the connection that a linear function, we better get rid of that. The linear function is a type of a discrete linear function. These are known as arithmetic sequences. So I want you to highlight that the linear function and arithmetic go together. So right away, let's jog our memory and talk about some things that linear functions have in common. Well, linear functions, and the most important thing, have a constant rate of change. What does that mean? Well, that means we're either adding or subtracting by the same thing each time. So they have a constant rate of change. So when we're talking about arithmetic sequences, that's what we're looking at. We're looking to see if it's adding or subtracting by the same thing for each pattern. So a constant rate of change. The other thing that I want you to remember for linear functions is the formula. Y equals mx plus b. And when we go to create some of these formulas today, don't forget what we learned in previous about how we get our linear regression into our calculator, Stat Calc 4. So Stat Calc 4 is one of the things that we're going to be referencing later on today is Stat Calc 4. Because we're going to talk about a linear regression, Stat Calc 4, to help create some of the formulas. So let's go ahead on to exercise A. Ivan is saving money Ivan is saving money to buy a new toy. She already has $12 in her account. She gets an allowance of $4 per week and plans to save $3 in her account. So out of that $4, she's going to save $3 in that account each week. So on week 1, she has $15. Week 2, she has $18. Week 3, she has $21. Week 4, she has $24. Week 5, she has $27. Week 6, she has $30. And week 7, she has $33. Notice that my pattern is adding 3. Adding 3. That's how we know that it's an arithmetic sequence. It's because we're adding each time. B. It says write a recursive definition for the sequence. Recursive. Remember we talked about in lesson 1 and 2 the word recursive. Okay, the prefix of RE, repeat. So we need to know what we begin with because you have to have something in order to redo it or recursive it. So A sub 1, we always start off by writing A sub 1 equals. Well, in this case, what does A sub 1 equal? I hope you can tell me now that A sub 1 equals 15. And A sub n equals, now this is where you write the recursive part, A sub n minus 1. Remember, right here, that's the big part for the recursive, the n minus 1. You have to do the previous term. Plus 3, because plus 3 is how much I'm increasing by, so that goes there, plus 3. Now C, what's wrong with the graph of the sequence shown below? Well, one of the things that I learned is that these should just be points. There should be no line connecting the points. Because if there is a line that implies, it's implying that there's data points in between here. And that is not correct. So we want to just create our points and plot our points, and I'll give you a nice trend. And if they may ask you about the slope, well, what kind of slope is it? Well, it's a positive trending slope. So they can ask you questions on that, but you should not be connecting these with lines. That's what's wrong with this graph here. And our last question on this page, Ivan proposes the following explicit formula. Well, that's the first time you've seen explicit. So really what the explicit isn't it in y equals mx plus b form? So when they talk about explicit formulas, that's what they're asking you for, is to put it in that formula. Well, they already did it for us. Now what they're asking for is for the amount of savings A as a function of the number of weeks saved N. Is this formula correct? Test it. Well, they want to know, is this the correct formula? So all we have to do is let's pick out one of our data points. The easiest data point to pick out and test is 1. So we're going to say 3 times 1 plus 15. 3 times 1 is 3, plus 15 is 18. So if we go up here and look at 1, is my output 18? If we input 1 like we did, do we get 18 out? No. So obviously that formula is not correct. What is the correct formula? Why is that one not correct? Well, if you take a notice right here, what is my y-intercept? What is my y-intercept? My y-intercept is 15. And if you look up here, does 15 have a 0 next to it? No, it does not. So one of the things that I would do is I would say, all right, if that is 1, then what is my y-intercept? My y-intercept, now I'm going to subtract 3 going back up, it should be 12. So my correct formula should be 3n plus 12. Arithmetic sequences are ones where the terms in the list increase or decrease by the same amount, with a unit increase in the index where the number is in a line. So my terms in the list increase or decrease by the same amount. So an arithmetic sequence is given using the recursive definition b sub 1 equals negative 3 and b sub 1 equals b sub I minus 1 plus 6. Which of the following is value for b sub 4? So it's telling me I want to go out 4 terms. So the first thing I'm going to do is create a table. I hope that I have that ingrained into you now. By every time they ask you one of these questions, organize it by putting it into a table. So 1, 2, 3, 4. Nice little list. B sub 1 is negative 3. And what does my direction say? How am I going to increase each time? I hope that you notice right away that you look right to that part of that formula and it says plus 6. So I'm going to add 6 each time. So my second term is going to be 3. My third term is going to be 9. And therefore my fourth term is going to be 15. So the answer here is choice number 4. Exercise number 3. Arithmetic sequences are relatively easy to spot and are easy to fill in, so to speak. So for each of the following sequences, determine if the arithmetic based on the information given. If it is arithmetic, fill in the missing blank. If it is not, show why. So the first pattern here I see going on from 5 to 9 and 9 to 13 is going to be plus 4. So because it's adding, that is definitely going to be arithmetic. And my missing blank is going to be 17. Let's go to B. How do I go from 5 to 10 to 20 to 40? I hope that you notice that it is times 2. This is not arithmetic because we are multiplying. So no, I'm going to put no there, not arithmetic. It's going to be called something geometric that you're going to learn in a few days. But right now, the answer to this question is no, it is not arithmetic. And the missing blank is going to be 80. C. How do I go from 7 to 4 to 1? Well, I hope you notice that it's minus 3. And in this case, it is arithmetic because I'm adding a negative. So in this case, it is definitely arithmetic. And my missing blank is negative 2. We look at D. How do I go from 64 to 16 to 4? Well, I hope you notice that we are multiplying by 1/4, or that we divided by 4. So therefore, my missing blank is 1, and my answer to this D is no. This is definitely not arithmetic. Once again, that's going to be a geometric, when we learn in a few days. Finding a specific term in an arithmetic sequence without listing them sometimes can be a challenge, but not if you take your time and really think about it. Consider an arithmetic sequence whose first 3 terms are given by 4, 14, and 24. What is the 4th term? How many times was 10 added to 4 to get to the 4th term? Show a diagram to illustrate this. Well, my diagram is going to be my table, x and y. My first 4 terms, 1, 2, 3, 4. They give us the first 4. 4, 14, and 24. The fourth term, because I'm adding by 10 each time, is going to be 34. And then asked how many times was 10 added to 4 to get the fourth term. The answer is 3. Okay, it was only added 3 times right here. So the answer is that just 3 times. Use what you learned in part A to find the value of a sub 10, the 10th term, applying this formula. Well, I have a formula that we're going to use, and that's called the arithmetic formula. It's going to be a sub n equals a sub 1 plus n minus 1 times d. D is going to be my change, right? My difference. So how much am I changing by? Well, that's my plus 10. So 10 is going to go in there. So a sub n equals a sub 1, which is my first term, 4, plus, kids always mess that up, don't forget that plus sign in there, n minus 1 times 10. So I want to just make sure that you notice that my a sub 1, my 4 is going in first. My plus sign, that is part of the formula. N minus 1 is part of my formula. Times d, which is 10. Because I'm increasing it each time by 10. In this case, the question's asking me what is the 10th term. Remember, term is the same letter as n, so I'm going to put 10 in there. I don't want you to get that confused. That's why I left it blank, and I'm going to put it in a different color. That is what term I am looking for. So now let's go ahead and do the calculations. A sub n equals 4 plus 10 minus 1, which is 9, times 10. Notice here, that's really the distributing property just written behind it. It just looks a little different. Do the same thing. 9 times 10 is 90, plus 4 is 94. So a sub n equals 94. Now what we like to do for this is write a recursive formula for a sub n based on the term number n. Okay, so the first thing we have to do when we're writing the recursive formula is write a sub 1 equals. A sub 1 equals 4 in this case. And a sub n equals a sub n minus 1. Remember, that's the big part for recursive. And what is my d? Plus 10. Now we're going to hold off on d until we get to class and writing the recursive formula for a sub n, because I would like you to use your calculator for this time. Okay, so I'm going to show you how to use your calculator to write the explicit formula right out of the gate. If you remember, we did stat edit, and that's how we're going to start it. Stat edit, and we're going to insert this table. So I'll hold off on that until we get to class. All right? Thank you. Exercise number 5. Seats in a small amphitheater follow a pattern where each row has a set number of seats more than the last row. In the first row, it has 6 seats. I'm going to underline some key information. And in the fourth row, it has 18 seats. How many seats does the last row, which is 20th, have in it? Show your work to justify your response. Well, in order to set this up and figure it out, I'm going to create a table. So I have my x, I have my y, and I have a table. And it says that my first row has 6 seats. I don't know what the second one has yet. I don't know what the third one has yet, but how I do know the fourth one has 18. I have to figure out that I have to count by what to get to 18. How am I getting from 6 to 18 quickly there? Well, I have to figure out that I'm going to be able to count by 4s. So that this is going to be 10 and this is going to be 14. So I see that I'm adding by 4 each time. And I just did some quick calculations there to calculate to see, well, I had to go from 6 to 18, which is a difference of 12 in three moves. So what is 12 divided by 3? 12 divided by 3 is 4. That's how I calculated that. Now I'm going to take the information that I have, and I'm going to plug it into that formula that I just taught you. A sub n equals a sub 1 plus n minus 1 times d. That is the arithmetic formula that is given to you. You do not have to memorize it. You do have to know how to use it. So a sub n equals a sub 1, which is 6, plus my n. In this case, what is my n? What am I looking for? My 20th term, so 20 minus 1 times d. My d is going to be, what am I increasing by each time? And we figure that out by calculating, and it is plus 4. I don't want you to get into a bad habit here by putting that plus 4 so big. So let me correct that real quick. It is a positive 4, because you're going to be multiplying, so don't get confused by that. So 6 plus 19 times 4. 19 times 4 is going to give me 76, plus 6, which is going to give me a sub 2. A sub n equals 82. Bring any questions that you have for me to class, and I hope you have a great night. Thank you.